My name is Levi Gildehouse. I am an applications supervisor here at Brewer Science. Um, I have been in the applications group for about a half decade at this point, and the primary function of my team is to do defect testing of the materials that are manufactured from the ground up at Brewer Science. And so we are really just a final true quality check of the materials that are coming out on a daily basis that are being shipped to customers around the world.
So I guess as far as a role at Brewer Science, we're the quality engineering team. So the things that we head up are the SQC, which is the statistical quality control, to ensure that materials are meeting customer needs prior to release and shipment, and things of like change control that ensure that we are maintaining consistency of our materials and customers are notified when things need to change. Driving continuous improvements through the use of change control, monitoring our non-conformances to ensure that material that is questionable is not sent to customers or the risk is reviewed. The non-conformance process that allows us to check and make sure that questionable material risk is mitigated, as well as excursion management, which is customer issues that we drive to root cause, and then using that as a systematic approach to try to drive continuous improvement across the manufacturing organization.
Okay, so now Meredith, whenever you're talking about, we're talking about change control and driving processes. As an instructor, what kind of things would I need to have in my classroom? You know, how could I help students understand what change control means? You know, what does that really mean if I knew nothing about manufacturing?
So change control is really boiled down to just ensuring that we are reviewing all risks prior to introducing something new into a customer's process. So the biggest thing that you would need to be aware of or have a skill set would be kind of structured problem solving or just problem solving. There are tools out there, but just a general problem solving mindset is probably the best thing that could assist in those processes.
So like whenever, are there certain computer programs that we use that kind of walk us through that process? Or is everybody acting like a detective and having to pull out of their head, you know, here's what I need to do next? How do we have that structured?
So there are key things across the industry like the 5M1E, which is different categories. It's method, man, material, measurement, environment, and machine. Those are the 5M and the E's that kind of guide a type. There's a Pareto analysis, there's the fishbone, there's also a thing called a FEMA, which is a failure mode effects that you can use to identify your top risks related to a process and start problem solving or putting risk mitigation in place for the highest risks. The other thing that we don't necessarily have a software per se other that would do all those things. They're more just techniques, but something that would be beneficial would be getting familiar with either Excel or JMP from a statistical analysis standpoint.
So hi, I'm Michael Wigan, and I'm an applications manager here at Brewer Science. And when you think about in the applications group, what the meaning of success is, typically by the time a material gets to manufacturing, it's considered a success for us. Because with our customers, we're usually already engaged with them on what their needs are and the challenges that they're having with their current materials. So we're always trying to improve our materials to get new materials in. So we're working hand in hand with that customer from an R&D level all the way up, you know, through our scale up. So by the time it becomes what they call a POR material, it's considered a success with us in applications because we've already done a lot of testing to figure out if we are matching or close to matching the process that the customer is wanting and those key characteristics that they need that material to do. So once it gets to manufacturing, for us, it becomes more of a monitoring to make sure that that material is not changing. Uh-oh, I can't hear you, Loretta.
Okay, I'll unmute myself. Whenever we talk about POR, you've used an acronym that maybe our teachers don't know.
So that's a process of record. Okay.
And so the other thing is, if we notice a material is changing, the customer's ordered something, got very specific requirements, what happens if we notice, hey, things are starting to shift? The product's not exactly like we thought it was going to be. There's been some deviations. What happens? What do we do whenever that happens?
So hopefully we catch that before it gets to manufacturing. But there are instances where, like with that monitoring, where we do see, we'll run the tests before we ship it to a customer, and if it's high in defects or that key characteristic that customer's interested in, then it flags, right? And then it goes to our quality group with Julie and Meredith, and they're going to sit down and they're going to do a deep dive of why. Obviously there's going to be some retesting, but what we do not want to happen is we do not want to send bad material to a customer. So that's one of the whole, main mantras I believe of a quality group, is to make sure that, hey, we've got quality material, it's consistent, and this is what we want, that consistency going to the customer. So we'll do a whole, all kinds of testing of that material before it gets to the customer.
What kind of skills do you think that student would need if someone's interested in working in the area of quality? What kind of skills do you think would be really helpful?
So from an applications point of view, you need to have a little bit of background on the actual customer's process. If you can actually understand kind of a high level of the process that they're using, then that's one key attribute. Another key attribute would be the customers at the very front line typically, and they're using the latest, greatest machinery, and we're not always going to be able to do that. So you're going to have to be very familiar with the applications tool sets in order to try to adapt that tool set to try to do some sort of correlation with the customer.
My name is Nick Brockensick, and I'm an applications engineer at Brewer Science. I've been there for 20 some years. And I think I just want to follow up on with Mike, and from some of this tool set stuff or mindset, I mean, it's in the applications group, we're kind of this bridge between quality and R&D, where we have to kind of have our hats in both situations. As Mike alluded to, we are, we're trying to test brand new materials using customer scale equipment. At the same time, we're also taking the QC aspect of these high volume manufactured materials and running them day in, day out, make sure the batch 1 is equal to batch 2 is equal to batch 3. And I think that's one of the really nice things, really neat things about applications is, at least within the Brewer Science world, is that we're kind of this bridge. And and as Mike alluded to, our group does we have to do a lot of kind of modifying and just thinking outside the box for, hey, can I use this piece of equipment or this particular module within this tool, and that's not used for QC, but can I modify it in some way to make it mimic what they're seeing? And so we're constantly, within the application group, we're trying to listen to R&D and listen to QC and try to manage that type of situation. And that's what really makes, I think, applications really fun, is because it's like, one day you're QCing, doing this, lot check to make sure everything's okay, and then the next day, or even in the afternoon, you're like, okay, let's tear this apart, let's tear this tool apart in this spot, and let's make it better. to make it match more with what the tool is, what the actual customer tool is.
I'm going to ask this because you mentioned that you've been at Brewer Science for a long time. Over the years, you have built on some of the same basic skill sets, but over the years, the products have become more complex. How has that caused you to recalibrate and to change your approach to problem solving?
Well, I think that's just, you just have to have the open mind of, listening to the R&D chemist. Well, hey, this does this. Well, okay, can I make my tool do the same thing, or can I make my tool more, tight and be able to detect that type of thing. So, a lot of it has been a change, in the semiconductor industry. I've seen the change in wafer size, when, R&D still does things on a small wafer scale. We're, in the applications world, we're doing stuff that's, 12 wafer that's 12 inches diameter versus a 4-inch diameter. So, I mean, I have went from 4-inch to 6 to 8 to 12, just to kind of, over that time. And those all bring different challenges to our materials. And so you have to be constantly on learning. You have to be constantly listening to the conferences. You have to constantly be going to looking at conferences, looking at, what, where all the customers are going, and trying to listen to what they are saying, and just try to keep that open mindset. It's like, oh, okay, well, let's try this and see what happens.
Yeah, another key attribute to that, Loretta, is like the communication piece. When we're that communication with the customer is going to be vital for you to understand why, 4 years ago, this certain characteristic we didn't care about. Now, all of a sudden, this one that this key characteristic is very important. And if we understand the importance of that, or why, maybe the material strips, or the material has a different etch rate, and that's very key in their process now. And for us to really tune that material to that, so that communication piece with, in that R&D stage with the customer is vital for success, I believe.
And
I'm sorry, Meredith, please go.
To build on Michael's comment, that's why I think process control is important too, because we don't have the ability to monitor all of the processes that our customers are, but we can identify key characteristics that we can monitor, whether that be a peak temperature, a flow rate, a filtration pressure, that can correlate with what our customer sees, so that we can add control around that characteristic.
Sure. Actually, just hearing everybody's piecing it together, there's probably something I can do to back it up and kind of tie it all together. So Julie Ply, Director of Quality Materials. My background is I'm a metallurgical engineer. And the simplest way to explain quality is quality is how well or not well a material conforms to its requirements, its specifications. And that's really what quality is about. So there's actually separate areas of quality that the team has all alluded to. There's quality engineering. Quality engineering is basically how do we ensure quality is part of a product design and a process design. And that's what Meredith is talking about. So basically, how do we control a process to ensure that a quality material is made every time? And then there's quality control, which is what I think Nick talked a lot about. And quality control is the measurement of the quality to determine how well we're meeting the requirements or not. But there's another aspect, which is quality management. And that's really at Brewer Science kind of what Matt and Bill do. And that's basically the systems that are in place to ensure our quality system is healthy. What's interesting is when you talk about conforming to customer specs, specs can be lots of things. It's not just a material requirement. It may be the requirements that a customer has for Brewer Science in how we behave. So for instance, if we manufacture a product that is not conforming, what are the requirements for notification to that customer? Or how often do we have to do certain validations, testing, things like that. So the customer requirements get very extensive. Some of these documents are hundreds of pages long. And that's a lot of what Meredith was talking about, change control. That's a big aspect. How we do control plans and FEMAs. So really what I do is I have quality control and quality engineering scope. So we're very focused on making sure the customer requirements are met. And one thing that's interesting is just in the course of 30 years in my lifetime, when I graduated from college, people talked about nonconformance in terms of percent scrap. And now we talk about performance of product in terms of parts per billion nonconformance. So you think about that, what that change in culture has looked like over 30 years may sound like a long time to somebody, but when you consider the magnitude, it's huge. And the requirements are getting harder and harder and harder. And so even very recently, Meredith and I attended a conference, and it was a lot of fabs and so forth talking. And one of their biggest areas for growth that they see is in the quality engineering segment, because they know it's going to take more of that attention to detail and design and process control in order to meet their requirements. Because we're literally trying to get every last bit of quality out of this stuff. And we're pushing our metrology to the point where we can't measure. I was just talking to Michael about this morning. When we test thickness at Brewer Science, it's kind of a black box sometimes. It gets very challenging if things aren't exactly right, because there's a lot of aspects to it, the same way there is for the applications team. And Darren Collins always puts it very well to me. Julie, when we're measuring thickness, you're literally splitting atoms. So you think about that. We're trying to measure something that's smaller than the size of an atom. And we're doing it day to day, every day on our C of A's for our materials. It's pretty amazing. And application takes it even one step farther than that. I think, Michael, you probably remember this, or Nick. What is the analogy for looking for a defect? Come on, you know it. What is it? It's something about
it's like
water.
Yeah, it's like something like like a golf ball inside of 5 football fields or something like that. In grass that's 2 feet deep or something like that. It's some crazy number like that. Yeah, that's the kind of quality that we're looking for in terms of defectivities now. It's just, it's crazy. My background is electrical engineering and physics. So I came to a chemistry company. And so I still make jokes with a lot of the chemists about, the chicken wire diagrams and stuff like that. But, over time it has, my chemistry understanding has grown. But also from the standpoint of, I think some of the mechanical ability. I mean, I was always interested in tearing stuff apart, put it back together. But you learn a whole nother set of systems. Some of the tooling that I work with has got a lot of pneumatic, and at least in some sense, some controls and hydraulic controls. And so I've had to learn a whole new set of vocabulary, as you mentioned earlier, on how to put stuff back, take it apart, put it back together. And that's some of the stuff that I've been working on when I've made some modifications, but at the same time, we look at, we think we got to have these super duper tests, that are super precise and stuff like that. But sometimes, when you're just trying to learn, just see if you can do so. Sometimes the low tech stuff works just as well. Levi has, Levi has experience in that, where we just basically filled, it seemed like miles of tubing up with some of our materials, and just kind of rotated it around, for a day or two just to test some stuff. And, it's just, plastic tubing and fittings. And he played hula hoop with them. That's what we say, with them for a couple of days. So sometimes even that low tech, some of that low tech, knowledge from LabWorks is sometimes the best thing for the test to do, just to say, well, okay, the customer says we're seeing these problems. Okay, it may not be, and I it may not be, do the exact same thing as the customer. It may be something completely different that eventually gets you to the same answer of what they're asking for. And so, from the standpoint of learning, there's no lab report. You have to write a lab report, but there's no lab procedure on this kind of stuff when you get out into the world. It's like, well, now what do I do? And a lot of times I think some of the learning that I've learned is just, what, let's just jump in feet first and see what happens. If you fail, I think, and at least Brewer Science is really good about that. And we're really good about this, is that if you fail the first time, that's okay. What'd you learn? Do better, and I think that's part of at least from the applications mindset is, okay, test number one isn't going to work. It's not going to be in a lab. Hey, you do this procedure, you're going to get out the right answer. You're going to be 2 or 3 procedures, 2 or 3 different procedures, 2 or 3 different projects down before you ever get to what you're really after. And so, that's kind of that's what I've kind of learned is, okay, there's no book for this. Just the simple troubleshooting thing that you can get from labs is kind of where you're at. So just jump in, start turning knobs if you can, and see what the output is. That's usually where you wind up learning more.
Well, I think that's a really big thing. They can't teach you troubleshooting in school. Like in school, you're given an equation and it's just a problem that you have to solve a very specific way. And here it's like, there's no, you have a desired outcome and your likelihood of getting there is, I don't know, somewhere between 0 and 100%. So, okay, yeah, the chance is there. But like, the point is that you have to try something, and failing is a path to success. Whereas in school, failing was just failing. And so, because there is a right answer. And here there is not necessarily a right answer. There's ways to do it wrong. There's ways to do it better. And just continuing to look for that way that is better than the previous way you were doing it, because you're never going to fully arrive at perfection.
Right. And then, from the quality standpoint is once you think you have the best answer, then you basically, from the quality standpoint, what Julie and Meredith are after is, okay, let's write this all down to make sure that we can do this again and get the same answer. And then let's do that again and get this third answer. And it better be close to the same. And Mike is talking, but no sound. Turn your mic on.
So yeah, one other key attribute to that, Loretta, is, is the networking, so gathering a group of that's one of the things that's so nice about Brewer is there's a lot of experts in different areas. So gathering those experts together and saying, hey, here's a problem that we have. There's not like what Levi was saying, there's not an answer in a book somewhere that we can just look up, but we need to solve this problem, and, getting this expert's advice and this expert's advice, and then designing those experiments to go test it. So
I think a good way to summarize that is something you're not taught in school is just having a solution-based mindset. Saying that something doesn't work isn't good enough. It's how are you going to test it to see how you're going to get it to work, or what options can you figure out as to why it's not working. And something that goes along with that is making sure that the things we identify are captured for the lessons learned are captured for people in the future. There's a lot of people who have been at Brewer Science for 15, 20 years, and they have more knowledge than, a lot of people, what you're going to learn in a book, and making sure that we capture that for the next generation when, they do move on to retirement. So when these issues arise, there is still a way to get that expert knowledge on a material. And there are tools that we have in place to do that, but it's important to make sure that once you problem solve, you're not done. It's making sure that you can apply it elsewhere in the future. I mean, honestly, I think from the overall quality perspective, it's kind of like math. Quality is quality no matter what. So it's the same language. I did not start in semiconductor at all. I came from agriculture, of all places, and moved into a world that's very different. But yet the terms in a quality situation and the items that you apply and the tools that are kind of the structural backbone from a quality perspective are the same.
So the biggest thing I've seen change in having to achieve new heights of quality is the collaboration with customers and suppliers. You know, back in the day, you know, the customer, it was, you looked at a customer visit as kind of a threat and, oh God, what are they going to find and things like that. Suppliers, we basically just bought to a specification. But now we're in a world where, you know, quite honestly, at Brewer, it's pretty unique. We don't actually get customer specifications sometimes. We do sometimes, but other times we actually develop those specs to indicate what we think it's going to take for them to achieve their desired outcome. And by the same token, with suppliers, they're kind of in the same place. We're asking for more every day. And sometimes we can't define what more means. Sometimes all we can tell them is what we don't want. And every day we learn more things we don't want. And that list becomes longer and longer and longer. And unfortunately, or fortunately, those suspicious relationships of 30 years ago have gone by the wayside. Because if we aren't all partnering in this, there's no way we're going to win because there's so much out there we don't understand. We have to work together and communicate and just be willing to disclose and be brave and not be afraid to ask the dumb question because you have to tell them where you stand. You have to be honest. And I have not found that hasn't paid off. We have a very good relationship with most of our customers, if not all of them. And we have a pretty strong relationship with our critical suppliers. So I think that is the biggest thing I've seen change in 30 years. Statistics. When you're looking at percent scrap versus parts per billion, you have to look at small segments of the population and derive conclusions about the whole population based on that small sample. And the only way you can do that is with statistics. I think that's huge.
There are a set of people who enjoy that area, and I think that goes along with part of their success is when they enjoy the statistics and finding those nuances, it pushes them to take it even further.
Well, yeah, from us talking about jumping on what Julie was saying there, statistics. Okay, I mean, the statistics class was pretty much where fun went to die because it's extremely dense, extremely hard. But in the end, we have software that does a lot of that stuff for us. It's just as long as you understand the inputs and outputs of what that software is giving you, what the statistics are telling you. And to some extent, you have to go through the dying part, I guess you could say, and to come out on the end to where you really understand, so that you can understand what those numbers mean. What the T-stat and P-stat and all that fun stuff is, and the R-squared and stuff. But you got to go through that to finally understand that. But as long as you understand the concept behind what those numbers are telling you, that, and been able to make a conclusion from that, and be able to infer stuff, and that's kind of where what I think is the big deal is the all, as somebody always said, like Julie mentioned earlier, let's ask the dumb, be the one that'll ask the dumb questions, because that's where you learn the most at, you know, and I think that's what I think is the most important thing out of it, is just to have that, that questioning mind, not being antagonistic about it or anything like that, but, always questioning, is this right? Is this, this goes back to this, the brewer science mentality, is like, is this good enough? Is this right enough? Is this, that always having that, that never ending search for, learning, for, I guess you can say empowerment, or learning, or, just a general questioning mind. This inquisitiveness is what I think drives me. You know, some of the stuff I do today, I would have never been able to do at Brewer Science when I first started, because I had no idea what some of this, what some of the tooling does, or how some of these things work within the tool. And so that's the kind of stuff that I think is the teachers should try to figure out how to foster it. And how do you do that? I don't know. How do you drive inquisitiveness? So that's kind of where I stand.
To play on what Nick says, in the applications field, I got a master's degree in semiconductor engineering, and I got out of school and I came to Brewer, and I was lost, because the industry is at such a, they're on the leading edge. They're right at the capacity of what the tool can do. They're right on the edge of what the actual process can do, and it is overwhelming. So what I try to instill with new employees that come out of college is, you know what, right now, I'm going to be perfectly honest with you. You can't do the job that I hired you to do, but I'm going to give you the time for you to learn and just absorb. And then, so don't be overwhelmed in the beginning. You should be overwhelmed, right, in the beginning, but like what Nick was saying, that just ask those questions, and just, you got to push through that. And if you can, in the end, obviously, yeah, it works out, but you're going to be very overwhelmed at the beginning, because the industry is such at the leading edge that the textbooks and the schooling aren't going to be able to keep up. They just can't, so.
Yeah, I think from Mike's side, I think that, he made a good point, is your first day on the job of any job, and that's the key, not necessarily Brewer Science, but any job, you're going to be overwhelmed. You won't know what's going on. Even if you go from, McDonald's to Hardee's, I mean, it's still a different job. It's got a different, even those two companies, yes, they're both fast food restaurants, but they have different ways of doing stuff. And so you're going to have to change your mindset, and that's kind of the point. It's always going to be different. You're always going to be learning as you go from job to job, or just within your job. And I think, that's kind of where you're at. First day of job, you're going to expect to be overwhelmed, but you'll get there. And I think that's, part of that whole learning cycle.
So I had to move downstairs. My computer was just about done. And the only other thing that I wanted to add was having teachers, force is probably the wrong word, but force upon students a teamwork and group mentality. Being in applications for my time in a manufacturing based company is primarily just a support role, support between R&D, support between manufacturing. My success is entirely derived from the success of the other groups within this company. And in school, it was never about that. It was, you get a passing grade, you get to move on from this class, versus your friend who didn't and has to retake this particular coursework. And my success here is entirely about everybody else around me, the people in my group and the people outside of my group, my customers, and my vendors. And so just being able to teach just how important it is to really build up the other people around you, because without their success, you really can't have your own. And I really don't know how to teach that in school. I have no interest in trying to figure out how they're supposed to teach that, but it was definitely a huge change in mindset coming into this type of environment.
Well, even from that standpoint, you might be the one running the experiment, but you had input from 4 or 5 different people, like you said, the teamwork, on what to test, how to test it, what should be our setup, and then you went to a couple other different people to like, okay, I'm having trouble struggling to understand what these statistics mean. Help me out here. Does this make sense? So you might have did the work, but like you said, that teamwork aspect is key. There's a whole background of people that you're relying on to help you guide you. And yeah.
Meredith typed something that said your customers can be internal, co-workers, and also external as well. So teamwork does matter.